Welcome to this video on binomial distributions. By the end of this video, you should be able to determine whether or not the conditions for a binomial setting are met, and you should also be able to calculate and interpret probabilities involving binomial distributions. All right, so in today's scenario, in the 2005 Conference USA basketball tournament, Memphis trailed Louisville by 2 points. At the buzzer, Memphis's Darius Washington attempted a three-pointer. He missed but was fouled and went to the line for 3 free throws. Each made free throw is worth 1 point. Was it smart to foul? That is our question. So, what are all the possible ways the shots could fall? In other words, he's going to make 3 shots. What are the possible outcomes of those 3 shots? So one way is, I'm going to say a check mark means he made it. And an X is going to be a miss. Okay? So he could make, all 3 of them. Another way is he could make, miss. Other ways he can do, he can make, miss, make, or miss, make. So you could have done this on your own. You can do this, a tree diagram would have worked really well to help you come out with all your outcomes. Miss, make, miss, or miss, make, miss. And there's 2 more possible outcomes of our 3 throws. He could miss, make, and finally he could miss all 3 of them. So what we're going to do is we're going to come up with some probabilities here. So Darius Washington was a 72% free throw shooter. From the probability that Memphis will win, lose, or go to overtime. When you have found the probabilities, put them in table 3. Okay, so in order to win, they are down by 2 points. So in order to win, he's going to have to make all 3 shots. So the only way he's going to win is make. Okay, so what is the probabilities there? So let's take a look at a couple things. So the only way they're going to win is this scenario right there. So up here it says Darius Washington was a 72% free throw shooter. So the probability of making it the first time is 72%. And now the second time. So this is make. So this is a multiplication situation. And then for our third time is also 72%. So this could be shortened by having written it this way. And that will equal 0.373. Okay? Now, to lose, if they're 2 points behind, they're going to have either they could miss all 3, they would lose in that situation, or if they have 2 misses, they're also going to lose. So all of these situations over here will cause this team to lose. So we have 3 misses, miss. So 3 misses would be, if 72 is a hit, 0.28 is going to be a miss. So that'd be miss, and a miss. Or you could have written it like this, and you'll get 0.22. The other option is he could make it once and miss twice. They would also lose if that happened. So we'll have a make it and 2 misses. .56. But this happens 3 different ways. This way, or this way, or this way. So we could add these probabilities together, but that would be the same as multiplying that by 3. So we would get an overall probability there of 0.169. And then our final scenario would throw them into overtime. That's going to happen if they tie. So that's going to, these situations here will make that happen. That's where he gets 2 makes or 2 points to get them to be tied up, and they'll go into overtime. So we have to have 2 makes and 1 miss for this to happen. So we have 0.72 for a make, 0.72 for a make, and 0.28 for a miss, for an overall probability of 0.145. But when we look, there's 3 different ways, this way or this way or this way. So we could add their probabilities together, which is the same as multiplying it by 3, because there's 3 of them, for an overall probability of overtime of 0.3435. All right, so we're going to take these and we're going to build on this and see what's going to happen. So first, let me show you what the foul look like so you get an idea of what's going on in this scenario. All right, so here they are, the final seconds of this game, and we're going to see what happens.
And he's trying to go 10 for 10 for the year. Nope. Gotta go in a hurry.
So here he comes to make his 3-point shot, and he got fouled.
Foul on Garcia. He got hit. There's Garcia.
Both behind right there. He's in air. He can cross that line in air. That's not a problem.
Darius Washington will go to the free throw line for the free shot. He's shooting 3.
And do the quick math, folks. They're down 2. 73 plus 3 equals a win.
All right, 73 plus 3 equals a win. So we're trying to see what's going to happen. So we're about to take this shot, and we want to see the probabilities of what's going to happen here. So really, we just work this out. So the score is currently 75 to 73. We have 3 balls that we can throw. So the probability of Memphis winning, the only way they're going to win is if they make all 3 shots, and we already calculated that to be a 0.373 probability. The probability that they're going to lose is going to happen if they miss all 3, or if they make 1 but miss 2. So this is an or situation, so we've got to take the probabilities. If missing all 3 was a 0.22 probability plus a 0.169 for the other probability. So that gives us an overall probability there of 0.191, so almost a 20% chance that they're going to lose. And then the probability of overtime will happen if they make 2 of them and miss 1 of them, and we have that probability there of 0.435. All right, so now what is going to happen? So we're going to watch to see what's going to happen in his first free throw. All right, let's see what happens.
For the season, 72%. If he hits 3 in a row, Memphis goes to the NCAA championship. 2 to go.
Boy, does that take the pressure off right now.
All right, so he made it. So now the score is 74 to 75. He has 2 balls remaining. So let's take a look at our probabilities now. So now, in order to win, he's going to have to make both free throws. So that's going to be a 0.72. So make and make. That's the only way that they're going to win at this point, which gives us, at this point, they have almost a 52% chance of winning the game. All right. Or he could also miss both of these balls. That would make them lose the game. That's the only way they're going to lose. So that'd be a miss and a miss for a probability of 0.078. So almost an 8% chance of just out and out losing the game. Or they could go into overtime if he makes one of them. So either makes and misses or misses and then makes. Both of those are possibilities. Those are or situations. So a make and a miss would give us an overall probability there of 0.2016, and there's two ways that can happen. So 0.4032, so a 40% chance of going into overtime. So there is a 92% chance that that either Memphis wins or they go into overtime. Okay, so things are looking good for Memphis right now. So let's see what happens on the second throw. Oh, he missed it. Oh no. All right, so let's go back and take a look and see what that does for us. So he missed it. He has one ball remaining. The score is still 74-75. So now, based off of this information with one ball remaining, what's the probability that Memphis is going to win, just straight out and out win this game? It's not possible. He can only tie at this situation. So there is a 0% chance that they're going to win the game at this moment in time. So what else is left? He's got one ball. If they're going to lose, he's going to have to miss this shot. So a miss has a 28% chance of happening because it's just one ball. Or if they're going to go into overtime, they have to tie, so he's going to have to make this shot. So there's a 72% chance that they're going into overtime at this point. All right, I wonder what's going to happen. So let's take a look and see what happens in this game. All right, so here he is. He's going to take his final shot.
Vern, I will be hard-pressed to tell you right now that if you'll see a more pressurized situation this year.
Tournament's on the line.
Oh, he missed it.
Somebody's got to go.
He missed it. Oh, no.
The first man there is John.
So he missed it. Louisville won the game. They ended up going on to the NCAA March Madness tournament, and the rest is history. But let's take a look. Was this a smart choice by Louisville to foul? So Washington, the person who was fouled, he's normally a 40% three-point shooter. So when he's throwing making a shot from the three-point line, he hits it 40% of the time. So was Louisville smart to foul? Why or why not? So if Louisville does not foul, Memphis has a 40% chance of winning. Okay, so that means Louisville has a 60% chance of winning if they do not foul. But if Louisville does foul, and the 40% comes from Washington's 40% free throw shots, or three-point shots, because that's what he normally does. So if Louisville does foul, which they did, they have a 37.3% chance of Memphis winning. Okay, that was that first one that we calculated. Memphis has a 37.3% chance of winning. And that's just winning and losing. Memphis could also win in overtime. So, was that smart? I don't actually know. Yes, maybe. It's really not that much of a difference whether or not they fouled. was a point when Shaquille O'Neal was playing basketball that he would be fouled a lot because he was a terrible free throw shooter. And so they knew he had more chance of making points if he was actually playing the game versus being fouled and having to do a free throw shot. So he would be fouled a lot because he had such a lower percentage of scoring in the free throw situation. In this one, it's kind of hard to say, but they actually had a lower chance of Memphis winning, but only by 3.3% or 2.7%. So it really wasn't that much of a difference for them. All right, so let's flip this over and talk about a couple of important items I need you to know. So the purpose for this scenario was to introduce the idea of a binomial distribution, a binomial setting. So binomial in math means two. So we want to have two conditions. So in this case, it's whether he makes the shot or doesn't make the shot. So there's a success and failure. That's the major idea behind a binomial setting. And there's these conditions, 4 conditions that have to be met. And using the mnemonic bins may help you remember. The first one that must be met is you must have a binary situation. Okay, and so that means each trial has a success or failure. Success or failure. And most things can be written that way. If I want to know the probability of car being red, we could have red and not red. That would be success and failure. When you flip a coin, you have heads and not heads. So you can write most situations in a binary scenario. The second part is your trials have to be independent. And we've talked about independent multiple times. So that one does not affect the other. Okay, so you got to be independent. And so his free throws, other than maybe a state of mind, but overall thinking, one free throw has nothing to do with the other free throw. They are independent of each other. Your N stands for your number of trials has to be fixed. And what that means is at the beginning, you know how many trials are going to happen. So in this free throw situation, there were going to be three throws. That's it. We already knew at the beginning how many it was going to be. So you know how many times the trial is going to happen before everything begins. And then your last is you have to have the same probability of success for each trial. So every time it's the same, that kind of goes along with your independent there. And every time you flip a coin, it's a 50% chance of a head. It doesn't matter what's already happened, it's still 50%. When he threw his free throw shots, he's a 72% free throw shooter, so he has a 72% probability of hitting the free throw shot. So you have to have the same probability of success for each trial. And so that would be your P equals something. All right, so now let's discuss the binomial formula, and we're going to go back to see how it relates to what we just did. So for your binomial formula, this is how it's written on your formula sheet. Leave yourself some room. We're going to add some writing around this. The probability that what I'm asking for is a certain thing. Probability that x equals a particular number equals nx. This is not a fraction. Do not put a fraction bar between those, okay? Px, and then 1 minus p n minus x. All right, so what this is this first piece here, this is really a combination. And hopefully you've done some combinations and permutations in your other classes. In your calculator, it's going to look like this. NCR, that's how you're going to input this. This is under your probability in your math button on your calculator. And so the N stands for your number of trials. And the X stands for the number of successes that you want. Okay? Then this P right there, that is the probability of success. So if P is success, 1 minus P would be everything left over. So that's actually your probability of failure. And X is the same. If X is successes here, it's also successes here. So X is the number of success. And N minus X is going to be the number of fails. Alright, so we're going to take this and we're going to relate it to what we just did. So you kind of see we were really already doing this, but here's the formula for how it works. So pause the video. When you're done, flip this back over to the other side. So I'm only going to look at this overtime scenario that we looked at right here, where we had to have 2 successes and 1 failure. Look at that. 2 makes and 1 miss. All right. There was 3 ball choices at the time. So we knew how many balls are going to be thrown. We knew there'd be 3. Okay. And then we have, for overtime to occur, we had to have 2 successes and 1 failures. So here's how this would look in the formula. Is the number of trials, it would be the 3 balls. We need 2 of them to be successes. Okay. So when you're putting that in your calculator, that would be a 3 combination, 3 choose 2. We have 3 balls, 2 of them need to be successful. Okay. All right. And then we had the probability of success was the 0.72. And we had 2 of those because we needed 2 successes. And the probability of failure was 0.28. And we had 1 of those because 1 of them would be a failure. So I'm going to put the 1 there. Normally you don't put a 1 exponent, but I'm really trying to help you see how the formula works. So this, if we look at the formula, there's your formula. We just did it without even knowing how to use the formula. Okay, we had this 3 choose 2. That comes from, that's where this comes in right here. There's 3 ways in which to get 2 successes. Okay, and so that's how that relates to what we've already done. So what I want to do is I want you to flip back over and check your understanding. So let me give you a little bit of help with this. You want to check the bins. Okay, so on the AP exam or anything for me, I write bins down the side, and then I want you to have proof for each one of these before you can say it's a binomial setting. So the scenario we have here is we're playing whack-a-mole. We know from playing in the past that we have an 80% probability of whacking the mole because we're awesome that way. The moles pop up randomly, and our ability to whack any particular mole is not affected by whether or not we've whacked the previous mole. That's saying independence right there. There are 20 moles to be whacked during 1 round of the game, and let X equal the number of moles you're able to whack. So let's see if this is binomial. So is this binary? Yes, we can. Success would be whacking the mole, and a failure would be a no whack. We missed them. Okay. Independent. It says that they come up randomly and your ability to whack any particular mole is not affected whether you whack the previous. So we'll say each whack is not affected by previous whacks. Okay. So we're good on both of these. So far, so good. Number of trials, is it set in the beginning? Yes, there are 20 moles will pop up during a round. So your N equals 20, so we're good there. And does it have the same probability of success each time? Well, we said we're so skilled in this game that we have a probability of success of 0.8. So we are able to meet all of these scenarios. So this is a binomial setting. We would be able to use the formula. Okay. So what I want you to do is pause the video. I want you to check your bins here. Oops, ran out of room. And then on number 2, check your bins. And then find the probability that you will win exactly 3 times. When you're done, come back and check your answers. All right, so after we played whack-a-mole, we started playing skee-ball. We know we have a 10% probability of getting any given ball in a 10,000 point hole. Let y equal the number of balls you must roll until you get 1 in the 10,000 point hole. So it's binary. You either hit 10,000 points or you don't. Each roll is independent from the previous roll, but there is not a set number of trials. It says until you get, it doesn't say what's the probability in 10 rolls, so we don't know. So once you hit something that doesn't meet your setting, you're done. That's not binomial. All right, and now we're going to play a game called Tsunami Duck Pond. And there's 100 ducks that get pummeled by tidal waves. You have to reach your hand into the tsunami and select a duck. If there's a star on the bottom of the duck, you win. The game claims to have 20 ducks with stars among the 100 ducks. After each round, you must place the duck back into the tumultuous water. Let W equal the number of times you win when you play this game 10 times. All right. So why is this a binomial random variable? So I have my bins. Success is you find a star. Failure is no star. Independent, you're putting the ducks back each time, so the probabilities are not changing. It's like pulling a card out and putting it back into the deck. The probabilities are not changing, so it's independent. Our sample is 10. Because it says we're going to play this 10 times. It told us at the beginning. And the probability of winning is the same every single time because we're putting the ducks back. It's 20 out of 100 or a probability of 0.20. So it is binomial, and because of that we can put this into the formula. So we have 10 ducks and we want 3 winners. So 10 choose 3. So in your calculator it'd be 10C3 to get that number. The probability of success is 0.2 and we want 3 of those. That means we have to have 7 losers at 0.8. So I got an overall probability of 0.2013. All right, that was a lot. Hopefully it was helpful. Let me know if you have questions. See you in class.